Okay, in the last module, we talked a bit about the big picture of the internet. Now we want to focus on how we identify different nodes in the network. What is the format of an address in the global internet, and how do I get there? For humans, we tend to work very well with names. We understand things like www.facebook.com. Computers, on the other hand, tend not to work as well with names because they're freeform and harder for a computer to process. Computers tend to like real numbers, things like 129.74.20.40, or hexadecimal like 00FA34:56. Now in this module, we're going to look at how do we blend the names that we as humans can understand together with the numbers that a computer would like to see. We'll look at the Internet Protocol, or IP, and how that blends together then with something called DNS, or the Domain Name System. So let's start off with IP. The Internet Protocol, or IP, comes in two primary flavors, IPv4 and IPv6. Currently, the vast majority of the Internet uses IPv4. For the purposes of this lecture, we just need to understand a little bit about IPv6. The key change that IPv6 is going to bring is that it dramatically expands the address space. It moves it from 4 bytes that we had in IPv4 up to 16 bytes. And what that is it means we go from having roughly 4 billion different addresses on the internet to a whole lot of addresses. If we think about every single person having one or more devices, IPv4 quickly runs out of addresses. Hence, with IPv6, they tried to future-proof it by having 16 bytes for the address. So if we get back on point, the IP address represents an effective address for the device. A nice abstraction to think about an IP address is a street address. How do you get to your house? Now the trick here, though, is a computer often does many things at a time. Hence, we need to figure out not only how to get to the machine or the street address, but also how to connect to the particular information source or application that we want to talk to. So each machine then has what's called a port, or a series of ports where we have 16 bits worth of ports, or 2 to the 16th, that gives us 65,536 different ports to properly delineate whichever application we'd like to talk to. Think about your browser you have open now. How many different tabs do you have open? Each of those might represent an individual port or connection that we might be connecting to. So if we think about it then, a port for an application is analogous to an apartment number. The street address or IP address gets us to the apartment building, and then the port number tells us which door we want to go to then. Well-known services tend to live on certain ports, so you might connect to port 80 to be able to connect to a web server, or maybe port 993 to go and fetch your email. Every packet then has this information included for both the source, where am I coming from, as well as the destination, where am I going to. A flow then constitutes the source and the destination of our IP addresses, as well as the source and destination port. We call this a tuple, and this flow then is sort of like a tube of information where I'm going to send packets from one side, my mobile device, out to the server on the other side and vice versa. When we write a computer program then to talk on the network, we call this for tuple a socket. An application developer then writes computer code to tell the operating system, whether it's Windows, Mac OS X, or iOS, to make a network connection to a particular server and port. Now for computers, this arrangement is pretty neat. For humans, however, this is a little bit rougher to remember. Hence, we're going to bolt something on top called the Domain Name System, or DNS. What DNS allows us to do is, instead of remembering ports or IP addresses, we're just going to remember names. So we might remember something like www.nd.edu, and what DNS is going to do is it's going to translate that name then into an IP address. Then we'll also include in front the type of resource we'd like to fetch. So we might put in http://, which then maps it over to the particular port number. This is all done automatically. So we can think of this much like a translator that takes our name and then translates it into something that computers can understand.